today. A bit about me real quick. I'm a third / fourth year CSEC major in the BSMS program from the great place of Long Island, like Mr. Chase Day right here. I do pep band, tenor and barry sax. You'll see me there every hockey game. Part of CSH's e-board and sysadmin team. I kind of just write code whenever I can, red, blue, all of the above, mostly Rust. So quick overview from Ash's presentation on the Linux file system. Here are all the cool folders you have. We're right there right now. We are just talking about this one folder in the file system. So what is it? What is ProcFS? Well, ProcFS is a very special directory in the Linux file system because it's entirely in memory. There are no physical files on disk for ProcFS. In there, it has all the defined processes and statuses of the system, along with some configurations that you can do through kernel parameters. A lot of it is very customizable and interactable because as with Linux, everything is a file. So everything is a file that you can either read from or modify. So first thing I'm going to is what's in just the root directory when you get into /proc. So one of the main things you'll see is system and kernel data. That might be in the form of CPU info, command line, modules being kernel modules. You'll see CPU and memory status. So again, CPU info will show you every CPU core you have, the model of the CPU, how many cores you have, all of that. Mem info, which I don't think I put on here. No, I didn't. We'll show you your current memory, kernel modules and statistics. So if you have, let's say, the ton module for VPNs, that would be in your /modules folder. And then drive and file system information. So /mounts will show you everything that's mounted to your system. And /file systems is all possible file systems that you support right now. Next, this is a fun folder. Proc/PID. So if you have a Linux system and you ls/proc, you're going to see a bunch of directories with just a bunch of numbers. Those are your processes. The number refers to the process ID of a given process. If you go in there, you can see a bunch of info about what that process has in it. For example, you can see what the binary is, what arguments were passed to it when it was running, the root directory, environment variables that's running off of, the current UID and GID, and the parent PID. So which process called that process. Also, /proc itself is a symlink to proc of PID, where PID is the current process. So if you cd into /proc itself, you'll end up in the PID for your shell. So whether it be bash, ZSH, etc. So I'll give you a bunch of examples: exe, command line, root, environ, and status. And kind of showing some important differences. Stuff like exe and root are going to be symlinks. So let's say you're looking at a Python 3 process. ./exe is going to be a symlink to the Python 3 interpreter. So the best way to look at those kind of files is using the file command. Because otherwise you're just going to get binary and you're not going to know what it's doing. If you do file, it'll say symlink to file path here. The other ones like command line, environ, and status are just physical files that you can read from. So those you can use cat or insert file reader here. Poking at a process, this was me like the other day, poking at probably my shell. You can see I'm looking at command self, which is pointing to it. If you file self, real quick, it's going to use the process that you called it from. So that's actually the process ID of file. So if you look in here, we go into the self folder. So I'm looking at my shells process. File exe shows ZSH. Root shows the root directory because I'm not doing anything weird. Command line, it's showing I'm using the ZSH command. And environ, that's every environment variable I have. I'm pretty sure there's no secrets in there. I don't know. ProcNet. So this is, you guessed it, network data. You can see basically everything that's going on with your network while in here. You can do TCP, UDP, ICMP, IGMP, raw sockets, which if you ever use a raw socket, they're very fun, and your auth data. You also have routes, like your routing table, and you can add IPv6 to the front of it to see the v6 version. That actually applies to most of these as well. Just add IPv6 either to the front or the end, it'll switch to your v6 equivalent. This is what TCP looks like. It's kind of gross. It might look kind of similar to what you have if you do like netstat or SS, but it's in hex because that's how the system chose to read it. So if you look at the bottom one, we're going to do a quick read through. It's actually putting them in reverse. So the firstmost byte is the end of the IP address. Because if you read from back to front, you have port 22, which is hex 16, and 129.2149208, 129.2112676. And you can see here, if you decode it, you end up there. So this is me SSHing into my machine. And inodes are something that are used with sockets. So you can use the inode to then trace it back to the actual process ID. If you read like the SS source code, the way that it does it is it just enumerates over every process, then searches for a socket in the FD folder, which is file descriptor, to try and find the inode that matches. This may look kind of similar to you. The top one is your /proc/net/route, and the bottom one is me running IPR, which shows out in a more readable format. So you can see here just how your system, when you call IPR, is actually looking at the proc file and decoding it into something that's a bit more understandable by a user. ProcFS, this is a lot of system kernel parameters, so stuff they can actually edit and it's not just readable. And a lot of cool stuff can happen here. Often you can pseudo echo a number or a parameter into it and pipe it to there. The same thing as using sysctl if you use that command, but instead of using dots, using slashes because once again it's a directory-based format. So notable ones that I wanted to put down was ICMP echo with goal all. That makes the system stop responding to pings. IP forward, if you're trying to use it as like a router or doing some weird man-in-the-middle activity, you want that on. You can mess with your individual interfaces or all interfaces. For example, you can disable op. Don't do it if you're SSH. It will immediately break things. Once you disable op, it will immediately try and only use hard-coded IP to MAC bindings that it knows of. And chances are your router is not hard-coded, so you'll just lose connection. Kernel hostname, don't do that. Just use the hostname command, please. And you can also change users maximum of basically anything, max inodes, max open files, max processes. So if you want to set a more defined limit to a user, you can do it from there. And yeah, defensive potential. That was a lot of data. We just looked at a whole lot of data. Red team's in there probably. If you want to find them, you can write some nifty little script in Python, since it's all just a bunch of files, and try and see if you can find any anomalies in that data. Or you can do it in Rust. Again, this is basically the same thing that your common CLI tools such as SS, netstat, and PS are doing, except this is where it's getting the data from. And for the good old offensive individuals here, the red teamers, you can definitely want to hide yourself in here, because once again, if blue team can see it, they can see you. To hide yourself from proc, you probably need a rootkit, because this is pulling right from the kernel. But as we saw, we can break a lot of interesting Linux things here, like ICMP, op. Although a lot of them do require root. If you have root, you may also be able to use this to find other passwords, other keys that you maybe didn't have before. For example, if someone's running a web app and they have a database password, an API key, AWS tokens, or credits, credentials, you can maybe find it in the environment variables if that's the way they're keeping them. And if you want to be extra nefarious, you can again limit processes or limit inodes, and then things will just stop working. That was a speed run of this presentation. Feel free to ask me more. I can talk about this for a while. Yeah, anyone have any questions for ProcFS? Hi.
If something was hiding in ProcFS, how would you find it?
To find something.
Like if something, let's say, was like with a rootkit, a process that, how would you find something if it wasn't easily visible in Proc?
So finding a rootkit is a bit beyond Proc. You have to check probably /proc/modules, and then you can see all active modules. It'll be hard for a rootkit to hide itself in there, I believe. Oh, it's probably possible. And if it's in there, you can probably try and decipher which one is fake or not supposed to be in there. Yeah, but yeah, if they're hiding their process from the kernel, then it's going to be hard to find it in proc because it's not going to show up as a PID. Any other questions? Cool. Oh, yeah. That's a good question. I have not attempted that. If I had to guess, it's going to just name it back after you run the command. Because again, it's all in memory. You're really not changing anything in the file system. So it's probably just going to, once you call ls again, regenerate what you have. Yep. Sorry? That's all I did, yeah. Probably because you had permission denied. Yeah, that'd be fun. Yeah, because that would probably break a lot of stuff, especially like the PID chain, because they would probably not be able to, they wouldn't be able to find the parent, or if it was the parent of something, it would stop breaking that. No? Right, we ball.